Good morning, good afternoon, and good evening. As we had a full house of over 100 Admire client attendees, or at least registrants for over the globe for this first time that we're doing a webinar like this, we are really over the moon that so many of you responded with great interest in this initiative. I have just started the recording, and we will try to do our best to compress it and to distribute it after the webinar, but at the end we will invite you to ask any type of question. So depending on the sensitivity of the questions, if you're disclosing some information that you don't want to see in the recording, it's always possible that the recording will not be distributed. But rest assured, we already have the slides online as well as the speaker notes. So the slides and the speaker notes will be available to you immediately after the webinar. Next to me, and I will just briefly shift the laptop over to the left, is my colleague Inyas de Roost, who you may have met or have interacted with in the past. He will be following up on the chat window. So if you have any problems during or after the webinar, he will be able to, he will try to do what we can to see whether this will work out. So my name is Bram Luiten. I'm a co-founder of Admire. And for the past few years, I've been very interested and working on Google Scholar indexing for DSpace repositories. For those of you on the call who are not very familiar with my interest and almost obsession in this topic, one thing that I did over the years is participation in the Open Repositories Conference Developer Challenge back in 2004, where I entered with a basic prototype of what would later become the analyzer software that I will demonstrate later in this webinar to you. But please be also aware that I'm not an employee of Google. I don't know exactly how the inner workings of Google Scholar works, but we have built a really good relationship with the Google Scholar team in the past, and we've been frequently interacting and exchanging information. So good, in fact, that when I circled out the slides of this webinar to them at the end of last week, that they immediately wanted to jump on a call on Monday night to put some extra emphasis and pointers into the content of this presentation to make sure that the most pressing issues and configuration topics would surface today. So they have been very much involved in the creation of this content. We have about 90 minutes reserved for this whole webinar, but there should be ample room for questions and remarks at the end. So I will try to keep it as short or as condensed as possible, but please do reserve your questions at the end and don't unmute your microphones, because only Inyas has the audio and I don't have it at the moment. So the content that I've prepared for you today is first of all a piece of theory, the basic principles for site-wide repository configuration, to make sure that as a whole that your repository can actually welcome the Google crawler or the Google Scholar crawler, followed by a range of item-specific principles. So after you have completed, or after your repository complies with these site-wide principles and items can be indexed, there are still some rules for items specific to be indexed into Google Scholar. After this theory, I will walk you through using analyzer.admire.com, which is a piece of free software that I basically developed in my free time to make this theory a little bit more applicable and to do detailed analysis of your repository and of your items with the goal of identifying problems and trying to make sure how you can resolve them. And as a last part of this presentation content, we will jump into Google Analytics. This is the free software offered by Google to report on usage data, so on downloads and page views, where you can really have some detailed reports on which traffic are you receiving from Google Scholar. So after knowing that your items are indexed, you can also really look at the volumes of users on a weekly, daily, or monthly basis that you're actually getting from Google Scholar and which content they are visiting. None of the information that I'm presenting you today is really original or is really something that I came up with. Especially those basic principles are a condensed version of what you can read on Google Scholar's guidelines for inclusion. I have a few links left and right in these slides. So normally you should be able to find a proper source and reference for most of the information. If I have a few informal points, so we have experienced a few things left and right that are really not official rules but are observations, I will try to do my best to make sure that I also indicate that it's that type of practical information and not really official spec. But first, before I go into these basic principles, I want to debunk 6 myths that have been passing through or that seem very resistant to any form of eradication. So even though this information is in documentation or it's been talked about at conferences, there are still some assumptions or some facts that just won't die. So I will try to contribute to getting these facts straightened up. First one of these 6 is answering the question, does Google Scholar rely on a repository-specific machine interface like the OAI protocol for metadata harvesting? Many crawlers indeed, and that's where the confusion comes from, such as OpenAir, Base, Core, just to name a few, they all very heavily rely on OAI PMH indexing. Google Scholar does not. It really treats a DSpace repository like any website or like any other repository system. And it, even though in the initial years they tried to work with OAI PMH interface, they saw that to scale up and to really harvest a big volume of very diverse sources, it just works better for them to really act like a crawler and think like a crawler and just see your repository as a website, try to crawl it and get that information out. So how good or how bad your OAI PMH is configured right now should have no impact at all on your Google Scholar indexing. Second myth to debunk. What does the site operator tell you about the coverage of your repository? And to show you what the site operator is, I will briefly jump out of the presentation screen share and switch the share over to my browser, if that works out. And I will go to Google Scholar and start a query that says site newdemo.openrepository.com. This is the infamous site query, and it tells me here especially this number or putting any value to this number of 28 is problematic. This does not mean that Google Scholar only has 25 items indexed of my repository for different reasons, but one of the reasons is that with the site query, you only find records for which the repository is the primary, and in many cases, not all cases, but is the primary version of the paper. In many situations, if you have scholarly content, for example, papers published in external journals, there will be many different versions of the web of that particular paper. For example, this one, and if I click here on all 9 versions, you get a list of all these 9 versions. It's not guaranteed that your repository will be recognized as the main version or the primary version, but those primary versions is the only thing that the site query shows. So I don't want to go into this too far right now, so I'm switching back to the slides. But you just need to know that the site operator is not a proper way to assess the coverage for your entire repository. Later on, I will show you another technique. If you want to know if a specific item is indexed, you can find that out. But there is no tool out there that says, okay, your repository has 50,000 items, 40,000 of them are indexed in Google Scholar. There is no tool that can tell you this right now. Myth number 3. Does Google Scholar effectively index all your items in the repository? And should it be your goal to have a full cover that every item that you have in the repository, that it also shows up in Scholar? It could be your goal if your repository is entirely filled with scholarly content, but there are many reasons why some items wouldn't show up. For example, if it's not scholarly content, but for example, special collections, digitized cultural heritage material, data sets is another example. And a second fact that is less known to some people is that Google Scholar also has a limit of 5 megabytes for trying to index your full text. So if it finds an item that is bigger than, or a bitstream bigger than 5 megabytes, the official recommendation is to get it indexed into Google Books, but that could also be a reason because they cannot parse that full paper or full plus 5 megabytes bitstream, that it will not be indexed. The next myth, how long does it take for an item to get indexed? And I specially added this to today's presentation because last week I heard from one of my colleagues that there's a repository out there claiming to their submitters that an hour after archiving into the repository, they can guarantee that it shows up into Google Scholar. I've never heard of such guarantees, and the Google Scholar team also has never heard of such guarantees. So if it's not 1 hour, how long can you expect it to get before it gets in there? There's not an easy answer to this question because Scholar crawls the different sources multiple times a week, but at the point of ingestion or the point when your item goes live into the repository, if you have bad luck, the repository was just crawled a day ago and it takes longer, it takes a few weeks. But as a rule of thumb, it's very strange, or it's already strange, or it should be a red light for you if the item still doesn't show up after a period of, let's say, a month. Especially, and that's an additional test that you can do to figure out if something is wrong, if more recent items that have already been added to your repository, if they are already showing up, but an item before that has been ingested earlier hasn't, then you know that something's up, or that could be a red flag or at least an orange flag to do a more deeper investigation into that particular item. Not immediately an answer to this question, but kind of a tangent is how long should you be able, or do you need to wait before changes to existing items get into Google Scholar? And the unfortunate answer there is that this can take potentially quite long, depending on how big your repository is. So Google Scholar does also do recrawls of older items, but depending on how fast the Google Scholar can crawl the entire repository, it might take several months for changes to existing items to propagate into Google Scholar. If you don't see an item immediately in the search results, does it mean that the page for that item in your repository is not indexed? So for example, let's say you get a report from one of your faculty who searches on his title and his name as an author, and he doesn't immediately see the repository record in the list of results. As I mentioned earlier, those different versions, it could be that the person has not clicked the link to all versions for a particular record and has not seen that on that second page the item is effectively indexed. The technique to really test if an item is indexed or not is to query on the exact item URL into your repository. It's quite simple. If you get 0 results there, the URL very likely isn't indexed. If you see at least something, some related records, it knows that Google Scholar knows the URL, but we'll see that in more detail later on. And then the last myth, and I hope if you have any other myths or things you're wondering about at the end of the presentation, feel free to ask. The last myth is it actually required to register your repository somewhere in order to get it included? And because there is a registration form out there, the link that I'm showing here, google.com/support scholar bin request.py, but it's actually not required to fill it in. If the site-wide principles that I will show to you later, if they are adhered to, Then Google Scholar should be smart enough to find your DSpace eventually and to get it indexed. If your repository is quite new, if it's already up for a couple of months, if you've tested it with my analyzer tool, and if all the green lights are there, and if it's still not showing up, then it's still worthwhile to fill in this form because it will give you the additional benefit that the Google Scholar team will have your email address as a contact person for that particular repository. So it's a good way to get in touch with them, and the documentation says that requests coming into that form take about 4 to 6 weeks to complete. Those were the myths that are now debunked, and I will proceed to the theory of the site-wide principles. So the site-wide principles, those things have to be in order before the crawler can index any item. So if you're currently in a situation, and being our client, I surely hope that you aren't, but it's always possible that some faults are in the configuration. If you don't find any items in Google Scholar, then there is a chance that these site-wide principles are problematic. Google Scholar treats DSpace like any website, so any of the technology of the tricks that are related to these site-wide principles, they just apply to any kind of website. Robots.txt needs to be in the root of the domain, and at the same time, robots.txt needs to reference a sitemap. Those are the two most important things. And if that just sounded like Chinese to you, then I will switch over to my browser again and show you what this means. I don't have to go. I go to my demo repository here that I'm using here, new demo.openrepository.com. Robots.txt is a file that you can find, or you should be able to find, in the root of the domain, which means immediately after the host name, you need to type robots.txt and then it should show up. Many people ask me, I've installed DSpace out of the box and it's under this context path XML UI dash or JSP UI dash. I have a robots.txt there, shouldn't it be good enough? The answer simply is no. Because if it's under a subdomain, how on earth will a crawler know that a certain subdomain exists? Crawler is a very simple thing, and it looks at a domain, and the first thing it looks at is what do I do, or what am I allowed to do, depending on what's described in robots.txt. And a very powerful tool that DSpace has, or has had for years, and has been a huge asset for the success of the indexing of the repository, is the inclusion of sitemaps. DSpace has two sitemap systems, one based on XML and one based on HTML. Google Scholar can work with both. Some other search indexes, I don't know by heart, but some only use the XML sitemap, the other one use the HTML sitemap. But it's basically a very simple machine-readable file that tells the crawlers immediately where to find the items. So let's go to this HTML map. HTML map is a simple thing that shows me the links to the items like that, but I was actually wanted to go to the XML sitemap. Because in the XML sitemap, you get an extra piece of information, which is the last date that it has been generated. So the sitemap relies on a cron job, which is a daily executed task that needs to run on the software, on the server, to update your sitemap every day. So if you look at your sitemap today, and if you see that the last update date is 2017, and if you're wondering why Google Scholar is not getting your most recent items, it's like an open goal or a very likely culprit. Other issues with sitemaps is if the URL is not correctly configured, so if it's still the URL of your test server or the URL that you had 2 years ago before you did your upgrade, it's really important that the domain referenced in your sitemap is the same domain as where you actually have the repository. So robots.txt, the sitemap, essential things that need to be in place for Google Scholar to easily find your items. Then, when those are correctly in place and working, you can safely tell the robots that they are not allowed to go into specific places. So with user agent star, you basically say all of the crawlers need to respect this. And then you can say things like, don't go to the discovery pages, don't go to the search pages, don't go to the browse pages, because you don't want crawlers to index all of the pages that are not items. You want to send people directly to items, directly to bitstreams, but you don't want them to land on a browse page or on a search page or whatever. So these disallows are perfectly okay, but these disallows are potentially disastrous if your sitemaps are not working or if they are not there. Because if your sitemaps are not working, the crawler will say, okay, no sitemap, let's just brute force try to follow every link that I can. But no, I'm not allowed to follow the browse links, the discovery links, anything else. So the combination of having your sitemaps in place and having these disallow rules properly configured is a good thing to have. Luckily, it's very good in the recent few releases of DSpace, so I would be surprised if you have problems with it, but still, it could be for some reason that the configuration was different. One thing that gets very often done is that the robots.txt just contains a very plain deny all for all user agents when the repository is still in some kind of testing or soft launch phase. And I have seen situations after a soft launch where it was forgotten to turn this back on, making it virtually impossible for any crawler to get to any page of the repository. One other note about crawlers and hits on performance. Crawlers can hit your repository very, very hard. And with very hard, I mean 10, hundreds, or 1,000 requests per minute, and they can bring a repository to their knees. One thing where you can control that and that you can put in to make the crawlers behave is something called crawl delay, which is an indication of you need to wait 10 seconds between every request. The nice thing about crawl delay, if the crawlers respect this, is that it enables you to keep your repository alive, basically. But the downside is, if you would put this on 100 or on 1,000, of course, the crawler cannot get to all of your content. So also an essential thing, if you get problems, to check what crawl delay you have in place. These were the site-wide principles. I'm switching back over to the presentation now. For some reason, I'm not allowed to do this. Yeah. Here I am again. And one last thing is pages should load fast enough. If a crawler is confronted with a very slow repository, it will mark the repository as problematic or maybe as down. If crawler sends a request and there's no answer coming at a specific time, it can also make the conclusion this repository is not available. Equally important for your human users, you don't want a machine or a person to wait more than 10 seconds for an item page. There are repositories out there that can deliver it in half a second, in a second, in, I don't know, depending on how big or how small a repository. So I'm not talking about the difference between 1,000 milliseconds and 3,000 milliseconds, but if it takes 10 seconds, 20, 30, a minute, this is not normal, and then it needs to be resolved. After your repository adheres to the site-wide principles, the crawler comes alive and will start to index your repository. And that brings us to, at that point, you can start to test items, or you should be able to find specific items. So the one rule or the one approach that works to assess your coverage or to assess whether there's something wrong with your indexing in Google Scholar is the following approach, and you can do it for as many items that you see as necessary. You take the URL of an item, in this case, new demo open repository. That's an item that I entered, I think, 2 weeks ago. So in this case, it was indexed 2 weeks ago. Even though in the initial result, I see no reference to openrepository.com, because in the item, in the search result, I see nih.gov, and for the file link, I also see an nih.gov link. That's just because Google Scholar said this is the primary record or the primary version of this publication. But then if you click on the all 9 versions, you will see that the repository record shows up. On the right side, you see that I have no link to my file. And the reason why this file is missing or the file is not being indexed will become clear when I tell you more about the item-specific principles. The item-specific principles, those are mainly the most important ones for this webinar, because I hope really to God, I really hope that your repository is not non-compliant with the site-wide principles, but it could be, and this is something that we as Admire sometimes have very little impact on, because we have no impact on how your users fill out the metadata of your items or what kind of operations happen on those items afterwards. So those could be very specific item criteria or problems. First of all, Google Scholar is only interested in scholarly articles and in sources with scholarly articles. This means that, let's say that you have a repository that you've been over the years using primarily for special collections. You have 35,000 pictures of antique vases from the Ming Dynasty. And then you suddenly have a collection that has 20 academic papers. That ratio of those 1,000 special collection items and then the 20 academic papers can have the result that Google Scholar just looked at your repository, sees this is not a source of scholarly materials, and just doesn't register the repository as a whole. This is a kind of a rare case, because in most cases, scholarly content is effectively the main body of what's in your repository. But if you have experiences with mixed content repositories, that might be something relevant for you. News or magazine articles, news for that. Book reviews or books, they have Google Books for that, and editorials, they don't see it as appropriate for Google Scholar, so those things should normally not show up. And as I mentioned earlier, there is this limit on the 5 megabytes per file. So if the bit streams get larger than 5 megabytes, you could also potentially see that those are not getting indexed. But also typically, I don't know how they will manage this in the future with more rich content formats or papers that become bigger. That might be an area of work or more complexity towards the future. So scholarly articles. Second thing, file formats. That's exactly the reason why my item that I had previously that had an XML attached to it, the XML did not get picked up because they say it's preferable to have it in HTML or in PDF format. And the PDF must have searchable text. It's a little bit technical, but it basically means that the PDF needs to have a text layer. If it's just a combination of scanned images that has no OCR on there, Google cannot do something on the PDF like, does it have the same title as the metadata? Does it have the same authors as the metadata? So it needs to have a text layer where it can search in. The next slide, and when I discussed it with Anurag Acharya and Monica from Google Scholar on Monday night, those were the ones that they say, put that in bold, make sure you spend enough time on this, because these are currently across every source, every DSpace that Google Scholar indexed, these are the biggest problems in December 2018 with indexing. The metadata. The metadata on your item pages is really important, because the metadata will be analyzed and will be compared with the contents of the bitstream PDF and with the contents of other versions that Google Scholar has identified for the same content. Basically, you have a paper, and Google Scholar also knows about the publisher source or the publisher version of that paper. If you don't have all of the authors, or if you are exposing the authors in a different order, then Google Scholar will conclude that the item is not the same, or that your item is incorrect and will not index it. And they say that nowadays they have huge problems with not all of the authors appearing, which is apparently happening in cases where repository content gets ingested from CRIS systems. For example, that the CRIS system is only interested in the institutional authors, pushes a copy into the repository that only has 2 authors and not the whole author list. If you don't have the entire author list, it can be problematic. So the order and the completeness of the author list is super important. Second thing that is a big issue for them right now are incorrect publication dates. They expect the publication date to be in your metadata profile in DC date issued. And the tags that I'm showing here on the left side, those are specific tags for Google Scholar that they are showing up into each item, and they are getting crosswalked from your Dublin Core metadata, from your standard DSpace item metadata. The note on author order, I don't know how many of you today are potentially on a version of DSpace 5.3 or older. So there was a specific bug in 5.0, 5.1, 2, and 3 that finally got solved in 5.4. And that was that the author order was notoriously crosswalked wrong in those versions of DSpace. So if you see some items not correctly, or if you see that the author order is different, and if you're not on DSpace 5.4 or newer yet, it could be an area to work on or to resolve. Here is one example of those metadata that are in an item page. If you go to an item of DSpace and if you right-click and go into View Source, then you will see these kind of sections near the top of the page, because these are the famous Highwire Press or Google Scholar tags that Scholar really relies on. So again, the authors should ideally be exposed as one tag per author. We have the publication date, and we also have the direct link to the PDF, to the full text PDF indexed in there. One question could be, okay, DSpace has a model where you can have more than one file in an item, so more than one bitstream in an item. How is it done there? When you edit bitstreams in an item, you can indicate that one of the bitstreams is the so-called primary bitstream. Primary bitstream is used to determine which one to use for generating the thumbnail, but it's also used for deciding which of the files gets offered to Google Scholar. One last word for those of you who are not on an Admire managed hosting or on open repository. If you run your own repository completely with maybe our support level or SLA support, but if you have direct access to your server and your code base, it's interesting to know that the configuration file where you find that mapping between those Google tags and the DC tags is in a very specific configuration file. So if the mapping needs to be tweaked, it can be done by config, and you don't need any, well, depending on what you want to do, of course, but normally you should not need any in-depth source code changes to make some changes there. And as one example, you see the Google citation date, and there you see 4 different Dublin Core date fields. The way how this matching works is that it works on first identified match. So it first looks at DC date copyright. This is the default configuration. Almost nobody that I know uses DC date copyright. If it doesn't find a value there, then it looks at DC date issued. But then, if it doesn't find anything in DC date issued, it starts looking at DC date available and DC date accession. And these are typically those dates that DSpace generates itself when an item becomes archived and public in the repository. So if you, during your metadata design, if you have decided, well, we're not going to use DC date issued, but we're going to use another date field, and you have not properly configured this in this Google metadata properties file, it could be that the mapping goes over DC date copyright, doesn't find anything, DC date issued, doesn't find anything, and ends up crosswalking those ingestion dates into the repository. So why have they been entered here as defaults? One angle that the committer or the contributor took, might as well have been me, I don't know who is actually responsible for this, is that the vision was it's better to offer any date instead of no date. But the Google Scholar people on Monday told me, always focus on the correct date. If you don't know what the correct date is, just don't propose a date at all. And second of all, if you have digitally stored materials where the first version is effectively your repository version, that DC date available or DC date accession might not be that much of a bad date after all. For example, let's say your digital thesis you give them a DOI or a handle as part of the repository, then maybe that DC date available does make sense as the official publication date of the record. So that's also a reason why it was in that default configuration. So these two things, the most important ones, correct author order, all of the authors, and the correct publication date are the most common problems that Google Scholar has with indexing today. There's also a number of optional fields. Those optional fields, if you have issues with those, will rarely be a problem with the indexing, but you could just fill them out or map them to make sure that Google Scholar has a bit more richer information. This is for journal and conference papers. And then for thesis, dissertation, and tech reports, there's also 3 very specific fields. Because those type of fields are often not in the standard metadata schema of DSpace, they're also not mapped by default, so it's very likely maybe that some of these fields are not being mapped right now, and it might be interesting, depending on what your experiences are with the indexing, that you may want to enrich your mapping to make sure that you're exposing these fields as well. How am I doing, Inyas? Am I talking too fast or too slow? Okay, he says it's fine. He says it's fine, so he's responsible. So the item principles recap is scholarly content only. Google Scholar needs access to the full text for max 5 megabyte, clearly linked from the item page and from these tags. And the metadata that's being exposed really needs to match with what's being exposed in those full text files. That's really key. If they see something like your author order in your metadata is already different from the file that you offered, then they look at the record and say, not a quality record, we may not index this. So this was all of the theory, and it's really good that you know, and it would be fantastic if you remember when you get up in the morning tomorrow. But if you don't remember everything, that's not a problem, because with the analyzer.atmire.com, I've built a tool to analyze A, your repository, and also B, your items specifically for these kind of mistakes. I don't yet have a test for problems with the publication date. Came out of the meeting on Monday that it might be interesting to develop something like this, but I do have tests for authors. So I'm not doing a live demo on this, but just walking through the interface. So if you go to analyzer.atmire.com, you will first see an overview of how many repositories have been scanned and how many items have gone in there. And if you then scroll down, you will hit a screen where you can start an initial analysis or get some initial results for your repository. All of that is basically accessible to anyone, so you can look at repositories from other people, see where they have done good things with indexing or what kind of issues that other people experience. Nobody has ever pushed me back on this, but if that ever happens, if I have to do some kind of account system and login, kind of want to avoid that right now to keep it simple. That initial analysis will already do a few things. It will recognize if your repository is up, if it's fast or if it's slow, what kind of version you're running, what kind of UI you're running, how many items you have. And it also tells you, you can also force a refresh of this information by clicking the button right there. And then you have a section that says which items have been found and indexed in Google Scholar, and that's related to the item analysis, about which I will talk a little bit later. So if you scroll down then, at the really bottom of the page, you will find a report against the site-wide principles that I've discussed earlier. So the analyzer does a test whether it can find robots.txt in the right place, whether you have the HTML map or the site map, whether your handle links are not blocked by specific robots.txt directives, or whether your bitstream links are not blocked. And if you land on this page, and if any of these site-specific principles shows up red, you will not be able to do the item analysis, because the item analysis is kind of blocked until the point when somebody is, until the point when you've cleared up that those site-wide principles. I find it quite funny that somebody is able to draw on the screen. Am I the only one who is seeing that right now? So that's a bit of a pity for the recording. So please don't do that, because I can see it, and I don't think I can do anything about it.
Yeah, everyone can see it.
So yeah, the site-wide principles are there. If you have a problem there, it will show you, and it will also give you a hint on how to resolve it. Next step is item analysis. And I will figure out how I can do something about these annotations. Erase batch or something clear. And I don't see my cursor right now. Annotate, clear, clear. All viewer drawings. There we go. I don't know. I didn't find it super funny, but now I'm annotating myself. And let's see when we get back into the sheet, into the lines. Okay. So after that, after those item-wide principles, site-wide principles, we go into the item analysis. So I have an item here. It's a test item. It's my Plan S compliant test item. So if you're interested in Plan S and making your repository compliant, totally not the topic of this webinar today, but clearly a topic of interest of many people at the moment. So I've taken the URL to this item, and I've put it in, I will put it later into the item analyzer, and I will just show you, if you go to that item on the new demo repository, if you click right and click view source, then you will be able to see those metadata tags that are exposed for Google Scholar. So it also exposes a bunch of DC tags there, but they're mostly interested in these ones, the ones that are labeled with a name that start with citation underscore, the so-called high-wire press metadata tags. I do see these markups on the screen again, and I will just try to investigate how I can just disable that overall. So I can clear all the drawings, and I might be able to set some setting to disable these annotations. No, I don't know how to do this. You know, here? No, okay.
Best click mute all again, so to make sure that everyone's muted again.
Yeah, okay. Mute all, okay. Okay. So indeed, these are then the metadata tags or the citation metadata tags that, that Google Scholar will go to. And indeed, you see here that in the citation PDF URL, I'm exposing the link to the XML because I've uploaded an XML file instead of a PDF one. So when I do the item analysis for the item, the analyzer goes, fetches the item metadata. It also tries to fetch the PDF or the file and do a number of checks on this. You can also, the automated part of the analysis, you can reset it and you can run it again. Why is it? It's partly automated and it's also partly manual. Why is it manual? The manual piece has been introduced because the initial implementation also had me do, or had the server do calls straight to Google Scholar. So would do a call out to Google Scholar to see if your item would be found, would screen scrape the results, and would automatically determine whether your item or your metadata shows up. But the formal terms of use forbid any machine usage of Google Scholar, and the recent improvements in CAPTCHAs and in bot blocking sometimes prevail these tests to go through. So one thing that you will see there is that there is a red bar that says item metadata not yet detected in Google Scholar. This will mean that my automated test has not been able to find the item, but you can follow the link. The link color is something that I will still improve, but you can click that link to say, click here to try out the query that was used to detect your item. And if you follow that query, you can look for yourself to see whether you can find the item in Google Scholar or not. And then the last paragraph says, if you have checked for yourself and if you found the item, click here to indicate that the metadata for this item was found. And then you can immediately yourself switch this green, red to green, and make it clear in the system if you want to keep a list here which items have been found in Google Scholar and which aren't. The same goes for the retrieval of the full text. There's a few other tests that I do on the metadata, whether the authors are exposed in a citation author or author tag, whether the full text link is available in the DSpace metadata. And if I can fetch the file, if it's less than 10 megabytes, I currently still do tests up to 10 megabytes. And if I can find out if the order of the authors is different between the file and what's happening, then I can show it in there. Another test is to do whether the authors are in alphabetical order. This also used to be one way to detect if the order is problematic. If the order is alphabetical, it's very likely that the order was manipulated, because it would be really a coincidence that the authors on the paper, the official scientific order of the authors would be exactly the same as the alphabetical order. So when you've tested a couple of those items, and if you go back to the page that has your repository details, you will see that those items indexed in Google Scholar will show up on your repository page. There will be a link to the item. The link to the item itself will be blue if the metadata is found, and will be red if the metadata is not found in Scholar. And the file icon next to it will be red if the bitstream is not found, and will be green if the bitstream is found. So that way you can do a number of tests by yourself before you contact us through the issue tracker, or before you contact Google Scholar yourself to help you out. And this should already be able to, detect 80 or 90% of the problems right there. There are a few more exotic problems out there and situations that can happen, really, really specific things. And I have one anecdote on this at the end of the presentation. But chances are very likely that you can find most of the issues with this approach. If there's any questions on the use of the analyzer, could be at the end of the webinar here, or maybe later on via email or whatever. I will now go to the last final part of the presentation. Is that, let's say that the site-wide principles are fine, Scholar is indexing you, your items are showing up. Then you're curious if somebody is really searching for your content and really finding the links to your repository. So is your repository really getting traffic from Google Scholar, and how does it compare to the traffic from other sources? Google Analytics is notorious in changing the user interface and changing the options around. So from every part of the webinar, I think that this is the one that's most likely to change in a couple of weeks or months. But the place where you need to go right now to get a report about where your traffic is coming from, so your so-called referral traffic, you need to be in the report tab on the left. You need to click acquisition. Then you need to do the drop down for all traffic and look at referral traffic. The referral traffic is the type of report that we look at in the next few slides. So initially, referral traffic shows you a number of sources, and these sources are links that people have followed, or where people have found a link to your repository or your item, clicked on that, and went through the repository. There is no guarantee that if your repository gets a request for an item page or a bitstream, that this referral information is present. Some people are masking it, some people are not sending it at all. So whatever data you get out of this referral report is really a lower end threshold. So it's not the maximum of traffic or not. It could be even more people that come from Google Scholar. A bit of a word about robot filtering and about abuse filtering. I sometimes hear that people put high trust in Google Analytics because of techniques of robot filtering that might be ahead of what the rest of the market is using. But two examples that I can immediately see right here is that I already have 3 entries for spam that are very likely not genuine traffic. So that 99 reasons for SEO, 9 reasons for SEO.com, or 17 reasons for SEO.com. Those are people that generate traffic or that send data to your Google Analytics profile with that information as a referral, just that you as a webmaster would see that, would click on it and would be interested in that. So it's the so-called referral spam. So this is just a tangent to say that the state of the art of usage data is that nobody on the market has a perfect solution yet. The DSpace stats can sometimes, we try to fight bots as much as we can or identify robot traffic. Google Analytics tries to do it as well. There's different technologies out there. And it's really still today a good idea to have multiple sources of data so that you can see and compare these sources of data and see what you can use for which purpose. But in this referral report, and right now we see that we have hits from Google Scholar, scholar.com.uk, scholar.google.co.uk. So we want to do a filter on what traffic are we getting from Google Scholar. So for that purpose, we are going to use the advanced filter. So if I go back to the previous slides, it's the box, that search box where it says the link advanced. If you click on that, you can add advanced filters. And then you can say the source has to contain scholar.google. And if you put in scholar.google, then you get all of the localized or nationalized Scholar sites in there. So that gives me a good idea of how much that traffic is. And in the user tab, the acquisition columns, you can see the percentage that this represents for the total traffic. So right now, New Demo is a demo site. It does not have a lot of valid scholarly content. So it does not, the percentage compared to my total amount of traffic is actually super, super low. And I hope that in your repositories that this is substantially higher. Another thing that you can do is you can filter on the network traffic of the users that are visiting your repository. So if you go to any website from your home internet connection, you may have some provider information. You may have Verizon or Telenet, Sky, or whatever local internet provider you have. But because academic institutions were so early adopters in the whole game of the internet, they often have their own network providers or their own network domains, which makes it really cool to filter on academic domains and to see which kind of visitors do you get from Google Scholar from particular academic institutions. So when I add this secondary dimension, so you always have 2 dimensions in a Google Analytics report, your primary dimension, your secondary dimension. If I now add this secondary dimension network domain, and if I put in a specific matcher or a query for a requirement for a domain name. So here for the network domain, I've had it AC because a lot of academic websites contain the abbreviation AC, or also ED for educational traffic, or you could do EDU or whatever. And then you get indeed the hits where we have a referral from Google Scholar and where we have a network domain in academic traffic. So these are kind of the things you can do a lot more or tweak more with it or get specific results. But the key thing is this is the place where you can look to find some information about the referral traffic coming from Google Scholar. What you can then do is you can, let's see what I had here. I also, one thing more, instead of the network domain, you can also look at landing page or the page if you're interested in which items or which pages are specifically consulted from Google Scholar. You can look at landing page as a secondary criterion, and then you have these kind of PDFs that are being downloaded by people from Google Scholar. The last thing that I want to show here is that if you, in such a report, if you scroll all the way up and if you click on the share button, then you can set up an email delivery, a regular email delivery of the report that you just configured. You can either do it in PDF or in Excel, but the very nice thing about a frequent report is that once you've established what's normal for your repository in terms of weekly referral traffic, let's say you have followed it for the last 6 weeks and it's not been a holiday, and you've consistently been getting 200-300 Google Scholar referrals every day, then you can set up this report to do a quick check every morning or every week to see if the traffic from the last day or from the last week, whether it was comparable to the traffic before. Because that allows you to have an active detection whether something on a larger scale is problematic for your Google Scholar indexing. Maybe something changed in the IT infrastructure of your institution. Maybe something happened with Admire's hosting. We try to do proper testing and do whatever we can, but we're still humans on this side, so there can always be temporary problems. But it will give you some insight 1 week, or if you have 3 weeks in a row where you go from 200 to 2 referrals, that's a clear signal. I mean, if you go from 200 to a week to 180, 190, it can go up and down. That doesn't say really much. But if you go from orders of magnitude in difference from week to week, that's definitely weird. And that could be one of the orange lights or red lights that would prompt a more in-depth investigation. And you can set up this kind of email delivery of reports for a whole range of different reports there. So this is a recap of the use that I just explained. You can get a feel for what your normal volume of Google Scholar traffic is on a day. You can set up a recurring report like this. And it all assumes that you care about Google Scholar as a source of traffic. If you wouldn't care about it, it would highly surprise me that you would have found your way into this webinar today. But it's just a low effort way of keeping on top of things and seeing if you get any mega improvements or any mega declines into that into those weekly flows of traffic. And then it's basically the last section of the presentation. So I've covered all of the basic principles, the site-wide ones and the item-specific ones. I've explained you how to use the analyzer.admire tool that can help you to find items with the typical problems that are known. But it's just a very general overview. There are many different types of operating systems. There are many different types of web servers. Your network department could do very specific things that are not standard or maybe very standard in your institution, but not outside of that. You could have very specific types of content, or maybe on a blue moon, there could be a bug on the side of Google Scholar as well, or problem with the crawl. And I want to tell you about a very specific story from 2 months ago. 2 months ago, I was satisfying my own curiosity and looking with the analyzer at specific repositories. And I tried, okay, let's analyze the largest public repository known to man, which is the Chinese IR grid operated by the Chinese Academy of Science. And I immediately hit a problem that is not a typical, but a site-wide problem. And one thing that crawlers and that my analyzer uses is a very specific query, not for an entire page, but just for the headers of a page. In technical terms, it's called a head request. And the Chinese Academy of Science has configured their repository in such a way that all level of head requests, of these type of header requests, that they are just forbidden. It's a Tomcat configuration setting that you can put in place. And when I touched base with them, they said, thank you for raising this issue, but we still feel that it might be relevant for our security to be in place. And as far as I know, it's not being fixed today, but here you have the largest repository in the world with over 1 million items. And I have not personally been able to find a single item of them in Google Scholar. So even if you're a very big repository, you could still be confronted with very specific or very kind of Frankenstein type of issues. So with that, I hope at least the majority of you hasn't fallen asleep by now. I wanted to thank you for your attention. We will look at the chat and the questions that have come in. And I already want to invite you to download the slides and download the speaker notes of the slides. They are behind this link. There's one little catch. We will have a few questions for you to see how we can improve our webinars, probably by disabling annotation for participants to start with, or ideas for content. Was this a waste of time? Should we do more investment into these kind of webinars? Was it useful for you? Was it just repeating something that you already heard? You can leave the feedback there, and at the end of the feedback form, you immediately get the link to the item where I've uploaded the speaker notes and the full slides. Thank you very much. And I will, well, Inyas has been looking at the chat and triaging the questions, and you will see which ones to address. There was a question from Andreas Heinrich, and he said, does the typing of the title have an effect on the indexing in Google Scholar? So I don't know exactly what the typing of the title means, but in any case, the field that it has to be in, so you can put your title in dc.title or in dc.title.alternative. But when I go back to that slide that talks about the configuration of the crosswalk, it should be properly crosswalked. But whether you have your title in caps or your title in whether you have a capitalization in front or not, if it's about the capitalization, I can hardly imagine that is a problem, or I've never seen that is a particular issue. But yeah, good question. Now, question number 2 from Marian Reed. What should we do if there are hundreds of authors? It's not uncommon in physics, for example, and in medicine as well, hundreds of authors. I asked exactly the same question to the folks from Google Scholar on Monday, and they say, okay, first of all, what I didn't know, but they apparently do it, they index all of the authors. So when Google Scholar finds a record in some source, they try to index all of the authors. So they will, if the item has 1,000 authors, they will try to have them. But if, for example, an item has 500 authors and you can provide the first 50 in the correct order, then he confirmed to me that the chance is already very, very high that they can match the item correctly. Because how many publications have exactly the same 50 first authors? There's probably not going to be a lot of them.
Perhaps we can show the last slide again so people can
get back to the link for the slides
that we had.
Yeah, okay, let me go back there. So it's bit.ly/admire-scholar-webinar-feedback. I'm not sure if we can keep online and find some few more questions if they are popping up. A similar question to the title question from Brida Hurley. Author names are in a different format from different publishers. Is the best practice to match the publisher's format, last name, comma, first name, or whether it's just without any separators? Great question. And from the inclusion guidelines, I read that 2 formats are acceptable: first name space last name, or last name, comma, first name. Those are the ones that they provide, that they have. Interesting tangent on this is I also asked them to which extent they've already embraced and support the ORCID IDs. They will provide me more information about that, but the basic way how they expect ORCIDs is that those alternating tags with authors, so we have an author tag, that they would desire that an author tag is immediately followed by the ORCID ID. So if we provide them with ORCID IDs in that format, the ORCID IDs should have an effect on the indexing as well. But we're still trying to get around the challenge of getting the ORCIDs in, getting them correctly indexed to authorities for different clients, but also for the open repository platform. So ORCID is definitely a moving target where we have invested a lot of time and effort in the past months. Alvin Hutchinson is asking, if a repository has a large number of restricted items, does that affect the Google Scholar indexing? Awesome question, but I assume it can. But one thing that can happen is if your site is entirely rejected before, for example, if they've crawled many items and if they've crawled so many of them that they couldn't find a PDF, maybe they will stop and they will reject the site as a whole. And as a consequence, you wouldn't see any single item anymore in Google Scholar. But as soon as you can find evidence that at least one item is indexed, and preferably a recent item, then you can have a relative okay level of confidence that at least the crawler is still visiting you. It's also possible, I've seen situations where for some technical problem or for some metadata problem, a repository gets rejected or gets excluded from the crawl. And to get it back in, you need that level of interaction with the Google Scholar team to say, okay, we know we had some problems before, they are corrected now. Can you please include us again in the crawl and get our items in there? And then they will do that, and a few weeks later, you should have the results visible there. Can the analyzer be used on any non-DSpace repositories? I spent already 10 to 15 hours of making it work for ePrints repositories, but I never finished that line of work. If there would be a reaction of saying, oh, we would really love to have at least the site-wide principles, because site-wide principles, it should all be pretty easy. But my very first check is, can I recognize this website as a DSpace, which obviously fails for other systems. So if there's a big demand for this, I might want to consider to make it more generic and have it work on other types of repositories. So nice to hear that there is some interest in that. Another question from Marianne Reed. We typically have added authors to match the way that we've previously listed them in the repository, but they are listed correctly in the DC identifier citation. It sounds like this might be problematic for discovery by Google Scholar. In one word, absolutely. So I don't really think, I would highly doubt that Google Scholar looks at the DC identifier citation field. So it would be advisable to have the authors in the same name or in the same way as they appear on the publications. Indeed, the result is that you get different name variants for the people in the repository, but hopefully again with the proper authority control feature and with ORCID in there, it would be possible to index, or at least in your browse by author or discovery index by author, to have a single entry, but for the different name variants of the person. But then we're indeed already talking a level of customization or level of configuration, depending on what version of DSpace you're on. How does Google Scholar deal with embargoed items? For embargoed items or for items where you have a non-standard bitstream, it's perfectly possible that Google Scholar will pick up the item record, and where you will see just a record for the item entry. But if it has never been able to test your PDF, if it hasn't found your PDF and matched your PDF, I'm pretty sure that the link to the PDF will never be advertised in Google Scholar. So I'm quite certain that embargoed bitstreams or bitstreams that are behind request a copy, for example, I don't think that those file links will appear in Scholar. Have one from Kimberly Chapman. Was there a discussion about cover sheets and Google Scholar? I had to step away for a couple of minutes. Cover sheets. Interesting topic, because there's a conflict of concerns right there. official recommendation of Google Scholar is anything that you do with the PDF that makes it look different from the other version that we found on the publisher can make it more challenging for our indexing or for the recognition of the items. One of the problems they highlight is that if a paper gets through different academic processes, they have a big problem with not one cover page, but a second cover page, a third cover page, a fourth cover page, so that they do not know whether their criterion has to be. They have criteria, basically, does the title appear on the first page or on the second page? Does the author appear on the first page? The author list appear correctly? Does the abstract appear? So the angle that we've taken with cover pages very often is to say, include a maximum of relevant metadata on your cover page, and then the automated checks to see if some of the data is present in there will also work against the cover page. And since many people will get the link to the PDF directly from Google Scholar, I'm personally, and with me many repository managers, I find the branding, the institutional branding on cover pages of bitstreams, I find it a super, super important tool for institutional branding on the research, because those users will generally not see your repository interface. And I made this case again on Monday, and they smiled and they say, yeah, we can understand there are very viable use cases and that there is a big interest in repository managers to have cover pages. They said they only can make their case. Anything that messes with the file, that makes it to a big extent different from the original, might pose a challenge. But I would just suggest, do the test yourself. Try to see if your item shows up. If you have a big pattern and if you see no items are showing up, all of the other metadata is in order, and the cover page remains as maybe one of the last factors that could be a determining factor. Maybe it could be still a factor for being excluded, but at that point, we would just open up a personal dialogue with Scholar about this, because we do see many repositories who have items with nice cover pages having those PDFs being indexed. So it's not that there's a very hard limit that says items with cover pages are not getting indexed at all. That's totally not the case right now. Could change their policy on this, but right now, that's not what we see in practice. We have Catherine Ruddock requesting, how does Google Scholar deal with public to private or private to public items? Private to public or public to private items. So the definition of a private item, like the one that you have the link to in the feedback forum. So we have exposed the item as an accessible item in the repository, but it's private, meaning that it's excluded from the sitemaps. It's excluded from the search. So basically a private item, Google Scholar has no way to go to a private item as long as the link to that item is not included in the sitemap. Once it becomes public, once the link is in the sitemap, it should be able to get there. But I do question right now if then that means that the item is not a recently submitted one, it's a very old one. You could be dealing with much longer update times because it's an older item and not a recent one. But it's an interesting case, and if you experience problems with this, it might be worth to analyze this in more detail. How to integrate analytics tracking config data when our repository is hosted by you or by Admire. So we have, if you have an existing analytics property that you already use, then we can configure it into the repository. But normally, well, in many cases, when we do the setup of a process, the project manager should ask, do you want Google Analytics? And if it's not been done before, a property gets created and gets added where you also have the admin access to those Google Analytics pages. And the best trick, if you are not entirely sure if Google Analytics is activated on your repository right now, let me just try to show that to you really quickly. So I'm changing my share again. to my browser. Yeah, Google Chrome. So if I go to new demo.openrepository.com and I request the source of the page, so I do view page source, then you can do a query for GA dash or analytics. Analytics, and then you find this, the very nasty or horrible looking script that has the Google Analytics code. And the important thing to look for is something that starts not GA, but it's UA dash. So all of the identifiers of Google Scholar profiles, they start with UA dash, and that UA dash identifier means there is a profile configured, and this is the profile where we are sending the usage data to for your particular site. If this UA dash is missing, if you look for something like this and if it doesn't show up, you can be pretty sure that Google Analytics is currently disabled for your repository. Great question, thank you. And I think that's all. So we will stop the recording also now. I don't think anything too sensitive came up. So if this all works well, I hope that we can add the recording as a bitstream to that same item where we have published the slide and the feedback. But in any case, we'll circle out if it's published. We will send you all an email with follow-up to make sure that you can find the recording. I thank you again for your participation, for your interest in this topic, and thank you so much for being an Admire client. You may not realize this, but over this past months, and I'm really saying multiple months, at least 30% of our team has been working on DSpace 7 every day. So that means thanks to the money that you're paying us for your hosting, customization, installation of your repository, you give us the resources to build the DSpace 7 for the future, also for the institutions that are not able to afford our services. So basically, thank you for your business and thank you for contributing to DSpace 7 in this way. Goodbye. Thank you.
Bye.